Welcome to the New Gravity Housing Conference session, A Tale of Two Buildings, Operational Performance Comparison of Phius Plus and Energy Star. I'd like to remind our attendees that everyone is muted with their video off. Please utilize the Q&A feature in Zoom throughout this session to share your questions with our presenters. We'll be monitoring this throughout the session, and we'll also have a facilitated Q&A at the end. Please use the chat feature in Zoom for side and general discussion. We'd like to thank our sponsors for their generous support of this year's conference. Make sure to check them all out in the virtual expo hall. Here's a brief message from two of our sponsors, ComEd Energy Efficiency Program and FAR Associates, before we get started with the session.
The ComEd Energy Efficiency Program has been helping owners save energy and reduce their operating expenses in new buildings and buildings undergoing major renovation since the start of the new construction offering in 2009. The program's impact has been tremendous. What you are seeing is a graphic representation of projected annual savings in kilowatt hours for new construction projects that have received both technical assistance and financial incentives from the ComEd New Construction Service from 2009 to 2016. The colorful bars illustrate a variety of building types that have benefited from the program, including manufacturing, higher education, retail, healthcare, and more. The program supports the transformational work of developers, building owners, and design teams.
The ComEd Energy Efficiency Program's Affordable Housing New Construction offering provides technical and financial assistance for projects to achieve beyond code energy performance while supporting occupant health and comfort. Eligible projects can be new construction or major renovation. They must be located in ComEd's service area. They must serve income-eligible residents earning 80% or less of area median income, and they must be designed and constructed in accordance with the ComEd multifamily standard. Contact us to learn more and get started today. businessee@comed.com.
Hi gang, I'm Doug Farr of FAR Associates, and we are honored to help bring the New Gravity Conference to Chicago this year. FAR Associates has been all in on sustainability for the past 30 years and has many great projects to show for it, including the Chicago Center for Green Technology, the Enel Net Zero House, University of Chicago's Keller Center, and Broadway Lofts, the region's first all-electric net zero multifamily project that broke ground last week in Gary. But solving the climate emergency one building at a time is too slow. So to accelerate change, we have stood up Carbon Free Chicago, a campaign for our region's prompt and equitable decarbonization. On August 20th, we launched the Common Agenda, a plan for the building sector to work cooperatively with local government towards the goal of requiring aggressive energy efficiency and all-electric building operations within the next 5 years. To join the August 20th launch of the Common Agenda, go to cfc2050.com. Thank you and enjoy the New Gravity Conference.
Thank you again to ComEd, FAR Associates, and all of our New Gravity sponsors. Now let's get into the session. Our speakers for this session are Charlene Andreas, Director of Building Development at LUCHA, Lindsey Elton, President at EcoAchievers, Connor Jansen, Technical Services Director at Slipstream, and Lisa White, Associate Director at Passive House Institute US. Here are the learning objectives for today's session. As a reminder, the New Gravity Housing Conference is approved for Phius, PHI, AIA, and GBCI credit. Thank you all for joining us, and don't forget to use the Q&A feature throughout the session to ask presenters questions. Now I'll turn it over to our speakers to get started.
Hi, so I'm Charlene Andreas. I am the Director of Affordable Housing at LUCHA, and I will be talking to you about our Tierra Linda apartments. LUCHA is a nonprofit housing services organization, and as part of our mission is to provide affordable housing for families who have incomes up to 60% of AMI or area median income. In 2020, that's $57,480 for a family of 4. So when LUCHA is setting rents for its apartments, we're considering overall housing costs for a resident so that we're not exceeding 30% of their income. Otherwise, it would be considered rent burdened. So housing costs is equal to rent plus utilities. So that points out that it's really important for us as a developer to also be considering the costs that are our utility costs for our tenants. So LUCHA does focus when we're doing our developments on energy efficiency. And with Tierra Linda, we initially started looking at these 45 units across 12 sites here with using Energy Star and looking at the Enterprise Green Communities criteria. We were also applying to ComEd for their affordable housing new construction program to support the projects. But then in 2015, our executive director had the opportunity to go to Germany and part of a leadership cohort. And there he was introduced to the passive house concept. And when he came back to Chicago, he came and said, are we doing this anywhere in Chicago? And should we be doing this at Tierra Linda? So LUCHA met with Phius and we discussed our project and we decided that we would do passive house here at Tierra Linda. Unfortunately, our funding sources were all committed at that point in time, and we had limits on how much we could spend per unit, and it really was not feasible for us to do all 12 buildings at the Phius certification, and instead we decided to do one building. So on this map that you see here, the location identified as number 6 is the Phius building at Tierra Linda. And then basically a block north, you can see the location identified as number 5. That is an identical 6-unit building, but that is built to Energy Star. So we saw here an opportunity with these buildings to potentially look at the advantages and the pros and cons of building to Energy Star for affordable housing versus Phius. And we were really hopeful that we would be able to take advantage of that opportunity. And so that was when we got to talking, Slipstream came along and they were interested in doing that. And so with that, I am going to hand it off to Connor Jansen.
Thank you, Charlene. Hi, everyone. I'm Connor Jansen. I work for Slipstream. We're a mission-driven, not-for-profit focused on energy efficiency and energy equity. And I'm going to dive right into the study that Charlene had mentioned. And for an overview, we looked at 2 brand new 6-unit properties that were developed by LUCHA. They were designed by Land & Bone Baker Architects, built by Lynn Mathis, and verified by EcoAchievers. Both of these projects were part of the ComEd Affordable Housing New Construction Program and had essentially the same layout, same orientation, and same location. The main difference was that they were constructed to 2 different energy efficiency standards: Energy Star Home Certification version 3.1 and Passive House Institute US Phius Plus 2015 certification. And this was a great opportunity to work with ComEd to help fund a study on how they compare across energy performance, construction and operating costs, and indoor air quality. Now, in order to do that, we worked across all of the units to wire up hundreds of data sensors and collect well over 1 billion data points. And as Charlene mentioned, the 2 projects were about a block away from each other. They looked a little bit different. On the left, you see the Energy Star property, and on the right, you see the Phius Plus property. And then you also see the 6-flat floor plan. And so you can see how the units were laid out with 3 bedrooms each. Now, where they differed, we'll walk through each of the key features. So the first one on measured air leakage, the Phius property had about a 4 times improvement on air changes per hour with about a half an air change per hour. On the ceiling or roof insulation, they're about the same, with the Phius property having R60 roof compared to an R50 roof. The Phius property had about double the wall insulation with R29.4, and that was through an EFIS wall system. The windows as well were about double the performance of the Energy Star property with a U value of 0.17. One of the main differences across the two buildings is that the Energy Star property used a high performance 2-stage gas furnace and central air conditioning, while the Phius property was electrically heated with a cold climate variable speed heat pump. On the Energy Star side of things, there was an exhaust driven continuous bathroom fan at about 40 CFM. And on the Phius Plus property, it was balanced ventilation with energy recovery. Both properties used power vented gas hot water heaters. Both had gas ranges. The Energy Star property had a vented dryer, while the Phius property was unvented. Now, the construction cost comparison between the two, the hard cost for the Energy Star property was $178 per square foot, and the Phius property came in at about 20% higher at $214 per square foot. Now, some of that cost was driven really coming out of City of Chicago requirements that guided this project towards that EFIS wall construction. Now we're going to get into some of the key findings from the study. So on the right-hand side, what you see is the daily average heating load per unit plotted against the temperature difference between the indoor temperature set point and what's happening outside. And what we see here first is that the Phius property on average requires 42% less heat to maintain temperature conditions. So that means that the Phius envelope is working. All of that insulation and air sealing is drastically reducing the heating load. Now, the cooling load analysis is still in development, but it appears to be about 14% less than the Phius property. So Chicago's a heating dominated climate, and a lot of our energy savings is coming out of that heating load reduction. And when we break that heating load reduction up, we see that the main contribution comes from the reduced air leakage in the ERV, which is about 54% of that savings. The upgraded windows also have a significant impact. And then after that, the wall insulation is still helpful, but the additional foundation and roof insulation aren't as big of contributing factors. Now, when we compare air leakage, and this is at air changes per hour at 50 pascals across several different buildings from a recent US Department of Energy study that Slipstream's been conducting, you can see that the Phius property significantly outperforms the rest of the sample size. And it's about 4 times improved over the Energy Star property. So really what this tells us is that having a tightly sealed building is possible, but it is not common practice. Now, one of the key components to having a tightly sealed building is to have balanced ventilation coming in. And we did see one of the issues with that balanced ventilation through our ERV, or our Energy Recovery Ventilation Unit. And we saw that unit freeze up for about 2 days during the 2019 polar vortex. That unit didn't have any backup electric heat, but a retrofit opportunity is in progress on that. And so on the right-hand side in that top chart, you can see the green graph there, the green bar, showing the temperature of the fresh air to the indoors. And you can see that dipping below freezing a couple of times when that unit froze up. And that caused a dip in the indoor temperatures below 60 degrees Fahrenheit. Now on the bottom side of this chart, you can see how the Energy Star property was faring. Some of the units were occupied, some were unoccupied. In the Phius building, only one unit was actually occupied during this freeze up. So that might have been one of the contributing factors. Another area of unexpected performance came through the heat pump operation. So these heat pumps were specified as cold climate heat pumps. They had a rated HSPF of 9.5 and a COP of 3.7 at 47 degrees. Now the chart on the right, the circles show the number of operating hours at a certain outdoor temperature condition and then the resulting COP. So if you first look at this chart and you see the operating hours at 47 degrees Fahrenheit, it's only around a COP of 2. That's pretty far off from the expected 3.7, and that's not even during extreme cold conditions. We'd actually expect these heat pumps to operate closer to what's in between the two dashed orange lines. But it was having a combined seasonal COP of only 1.69. And based on some other research and literature review, we'd expect those seasonal COPs to be closer to 2 to 2.5. Now on the cooling side, the performance was better or closer to the rated condition, but it still didn't meet expectations. So this is an ongoing area of study. Now, we alluded to this project saving energy, and at the end of the day, we saw a 36% energy savings when it came to a normalized EUI comparing the Phius property to the Energy Star property. And so when we say normalized, we essentially took out the differences in energy consumption that were really driven by occupants. So we averaged out the consumption from lights, water heating, and appliances between the two. So the normalized EUI for the Energy Star property was 52.5, while the Phius property had a normalized EUI of 33.7. The chart on the right compares the Phius normalized EUI to the WUFI design model that was put together as part of the pre-certification process. And we see that the WUFI model had an anticipated EUI of 23.1. We also did a simulation with an eQuest model following ASHRAE 90.1 Appendix G procedures and had an EUI of 24.6. Both of those model cases did a pretty good job at estimating the space heating and cooling requirements, as well as the fan usage. However, the appliance usage and plug loads were the contributing factors for these two values not fully aligning. When you take into account the 36% energy savings, it's really important to understand how that energy savings actually translates into utility cost savings. And when you compare the two properties, the Phius property has an 18% less utility bill than the Energy Star property. And the energy savings really comes from kind of an area that you wouldn't expect. It's actually driven by differences in the gas fuel prices between the buildings. So in Chicago, if you have a gas heated building, you pay a different rate for your therms of natural gas than what you'd pay for in an electrically heated building. So you can see some of the differences in these rates in the table below the chart. And so in order to increase the overall utility cost savings, it's actually important to cut the gas connection in this case. And you can see still here that there's still a monthly service charge for the gas hot water heating and cooking appliances of $22 a month. So if you remove that gas connection, you can actually increase energy cost savings from 18% all the way up to about 30%. And you can see that in the top chart here. But it's important to realize that to get to that 30% savings mark, you need to move from a conventional electric water heater to a heat pump water heater. Now, when you do that as well, you would nearly double the amount of CO2 equivalent emission savings between what we looked at originally with this building, which was gas hot water and heat pump heating, to heat pump hot water and heat pump heating. So we could get nearly a 60% reduction in CO2 equivalent emissions. Now, we'll talk a little bit about the adaptation of the reset standard to review the indoor air quality performance. So the Phius building, as we talked about, was constructed pretty tightly, and there really isn't a lot of research on how natural air leakage contributes to providing adequate ventilation. So we needed to establish a set of metrics on what accounts for good indoor air quality for comparison. And in order to do that, we used the reset standard, which is a monitoring-based standard, really designed for commercial spaces, but provides a useful benchmark for residential. And you can see on the right the different acceptable levels of 3 key pollutants. So PM 2.5, total VOCs, and CO2. So when we start to look at these levels, as well as temperature and humidity in the spaces, it's really important to understand that the unit occupants have a large effect on indoor air quality parameters. When you look at the charts on the right, the bar in blue shows the daily maximum range of each of these components when the units were unoccupied. So this unit was unoccupied for about 3 months. And you can see that the levels are actually quite low over those 3 months. But as soon as they become occupied, there's large spikes in all of the parameters. So moving outside of one unit and now comparing the whole Energy Star property to the whole Phius Plus property, you can see on the right the amount of days within limit for the reset acceptable level in blue, and then the reset high performance level in orange. And most units pass the acceptable threshold for both CO2 and PM 2.5, but none of the units met the threshold for total VOCs. And this is across both the Energy Star property and the Phius Plus property. What we could take away from this analysis is that there was no statistical difference in indoor quality between the two properties. The Phius property at the end of the day got about 50% more air exchanges than the Energy Star property. The relative humidity for the Phius property was significantly better, being in the range of 30 to 40%, while the Energy Star property was consistently below 30%. In the summer months, we found that the humidity was well controlled in both properties. Another takeaway from our indoor air quality assessment was the importance of bathroom fan usage. And this really only accounts for the Energy Star property, which had an average unit ventilation rate of approximately 60 CFM. And the background ventilation or continuous flow was between 30 and 40 CFM for each unit. Each of them also had the ability for boosted operation to ramp those fans up to about 110 CFM. And you can see from the chart on the right that only one unit consistently had that fan in that boosted mode, while some of them only had that fan light on, or that bathroom light on and fan running for like 10% of the hours. So having continuous ventilation is really an important factor to getting good air changes within these units, in lieu of relying just on a light switch to control exhaust-driven ventilation. The last thing that we'll touch on here is oven usage and CO2 and PM2.5 spikes. So we looked at over 800 oven use events within this study. We found that the Energy Star property, which has a manually operated range hood, would use that range hood about 40% of days that the ovens were used. And the Phius property had an exhaust pickup within 8 feet of the oven as part of the energy recovery ventilation system. Combustion from the natural gas by the oven itself really produced a large plume of CO2 and PM2.5. And under both of these exhaust scenarios, it took upwards of 4 to 6 hours to bring the levels of CO2 and PM2.5 back down to that baseline. And so this is an area that, I think we can think of as a potential to improve our designs for how, occupants are actually using the building, and we can think about, pause. So this brings us to the conclusion of the research results, where they stand today. I'm going to hand things over to Lindsey to talk a little bit about the verification side of things, as well as some of the work that they did on the blower door testing as part of the research study. And then we'll go back to Charlene, who'll talk more about how these items can connect back to how we can better design our buildings for our occupants.
Awesome. Thanks, Connor. And hi, everyone. My name is Lindsey Elton. I'm the president and partner at Eco Achievers. We're a green building certification firm that does all the green building certifications. And we were fortunate enough to work on both of these projects for the Energy Star and Phius certification, as well as be a part of the research study. So it was a really cool perspective to kind of see the evolution of both the Energy Star, Phius, and be a part of all those billion data points, I believe, that Connor had said. So as we're moving along, I just wanted to give everyone an understanding and a foundation of where Phius lands. So within the realm of green building certifications, there's really a couple of buckets that the certifications fall into. Some of them are more comprehensive and take a broad scope of things like LEED, Enterprise Green Communities, and GBS, while others take a more specific look at the sustainability lens and are focused more on energy or wellness or water, indoor air quality, things like that. So the Phius certification, from this perspective and from what you can see, is further on the scale in terms of advancement, and it really focuses on energy, durability, and indoor air quality. And so when you're pursuing a Phius project, you're actually getting certifications in all 4 certifications. So you start off with Energy Star, which has its own checklists and requirements and performance thresholds. And then you move to Zero Energy Ready Homes, which has a more advanced energy target. It brings in domestic hot water efficiency. It brings in some other requirements for appliances and air handler location. And then what it also does is it requires the Indoor Air Plus program. So what we've done is we've tightened up the envelope. We've made sure that things are really efficient from a modeling perspective, from an energy perspective, from an envelope perspective. And then we make sure that the people who are inside these buildings and these units get the best indoor air as possible. So that's what the Indoor Air Plus program does, is it takes a look at the interior and exterior durability strategies. It looks at radon, it looks at filtration, at low emission materials, and all these different things. And so we have all those programs in addition to some of the Phius requirements, and you get the Phius certification. So now that you kind of know a little bit of what is entailed, as you're moving along into the certification process, we get into mid-construction. So at this point, we've made sure that all of the certification requirements have been answered, or at least are projected to be answered. All of the models are in place. And now we're looking at what are the features of the constructed building. We're looking at framing, we're looking at insulation, at air sealing details, which is core to the Phius program. And the role of the rater is really the in-between of the design team and the certification team, and we're really there to make sure that what was designed is what is being built. So in addition to some of those visual verifications that we're doing, we also like to do mid-construction testing. And this isn't a requirement of the certifications, but we find it to be a super, super helpful tool for the project teams to understand where they're at and how good of a job they've been doing, and the efficacy of some of their air sealing and duct sealing, so that if there are issues and if we need to make modifications, we can do it at a point where it's not going to be super costly, and it's not at the end of the project and people are knocking on the door and waiting to get in and occupy the building. So that is something that we did with this project, and it was very beneficial. And once we got through the mid-construction, then we went into our final testing. And if you can imagine, the Phius final testing protocol is quite robust, just like everything else in the program. And we did whole building blower doors, we did unit blower door testing, duct testing, ERV, testing and balancing, ERV wattage, we did the domestic hot water efficiency, the IR cameras that you can see, as well as every other kind of aspect of the building, to confirm that in our models and to confirm that for our QA reviewers, so that they were comfortable in knowing that everything that was designed is required by the program was met. And at the end of it, you know, I wish I could have something kind of juicy and tell you that, you know, this happened or that happened. But really, and this is a testimony or a testament to how good the project team was, it actually went really smooth. The team had familiarity with each other, so we knew each other before. They had experienced the Tierra Linda project, as Charlene mentioned, had a number of different buildings in it, so they kind of got their practice. And when it came time for the Phius building and going through with that, it just, those steps to get to that higher level were a little bit, weren't as high of a jump, because they were already used to the base foundation of Energy Star. Some specific things that actually happened during mid-construction, which was interesting, that had never happened before, was we did the mid-construction whole building blower door test, and the EFIS insulators wanted to wait to hear that we met our blower door target before they installed the exterior insulation. So they wanted to make sure that that exterior envelope, that all the holes and all the cracks and crevices had been filled before they took that extra step. And then once we got to final certification, we really didn't have a problem with any of the blower doors or the duct testing. One thing that was interesting that actually happens usually on a lot of our projects was with the testing and balancing verification and just kind of knowledge of the industry, and with Phius standards being slightly more aggressive with ventilation airflow rates, and the TAP contractor wasn't as used to it, so it resulted in a follow-up visit. But outside of that, we were able to work everything out, and we got certified fairly quickly. So as Connor mentioned, with his research study, we were also a part of the research study from the testing angle. And this low-rise research study was carried out throughout the US on new construction buildings, low-rise buildings, 1 to 3 stories. And what we did is we worked with these 2 buildings on the Tierra Linda project, and we did the blower door testing, but a slew of other items. And I'm not going to go into all of those, but I just wanted to kind of highlight a handful of cool aspects. And so what we did is we did compartmentalization testing, and that was the unit testing. And what that does is that measures leakage to the outside, to the exterior, but it also measures leakage, or it includes leakage that happens in adjacent spaces. So the conditioned units above, the conditioned units below, in the hallways, everything. The whole building blower door test, on the other hand, is just measuring leakage to outside. So it's not taking into account the different spaces in between, because all of that is considered one conditioned space, and it's only measuring exterior leakage. So we did both of those tests. And then we did a third test, which is called guarded testing, where we combined both the whole building and the unit compartmentalization test. And what that allowed us to do is that allowed us to get just the exterior leakage of the units and negate all of the communication that happens with the other units adjacent to it, as well as hallways. So the results that we got, and Connor actually mentioned this, but these are the actual data points. So this is the whole building test. And when Connor had mentioned the whole building for the passive house was 0.5 ACH, that's actually our chart on the right over here. And then our Tierra Linda Energy Star project was at about 2 ACH, and that's reflected in this chart. So just kind of to get a sense of what the actual graphics are and the data, that's what we saw. On this next slide, it can be a little bit confusing, but the point of the main point of this slide is that on the left, we have accumulated all of the exterior leakage. So that's all the leakage that's going outside of the envelope, or you can kind of think of it as the energy leakage that happens that you're paying money for, versus the total leakage that happens to conditioned space. So maybe that you're not, you know, losing as much money for. And when you look at it on the second graph over here on the right, the point is that it's really kind of a messy, variable result. And just because you have a certain threshold, or you've got a certain result of exterior leakage, it doesn't mean that it's going to perform the exact same way with total leakage. This is actually what happens. And it's dependent on a number of things: where the unit is located in the building, pressures on the building, and what this means as energy professionals is that you can't really say that if you test a unit itself, that unit is representative of how the whole building will perform, and vice versa. You can't say that the whole or that the unit is going to perform a certain way because the whole building performed a certain way. And then this last slide is just showing that of the different floors, that the third floor units were often the leakiest unit to the outside. And the reason why they thought this was the case is because often those third floor units, instead of having a flat roof, they had a roof, or they had an attic above it. And it's just really, really tricky to get that attic completely isolated from the units itself. So as industry professionals, that's something that we can take as a take home and guide our project teams and have them concentrate on those areas, because we know that that's a common leakage point. So to wrap everything up, the overall findings with this is that the connectivity to adjacent units was pretty high. The top floor had the highest connectivity and had the highest exterior leakage, and that we can't assume that whole building tests that are super tight will translate into unit tests that are super tight. We also saw that depending on the type of building it is, so if you've got a vented versus an unvented attic, you saw different leakage amounts there. And then we saw that we needed to take a variety of different tests to really get an assessment of where buildings were and how they were performing. One test does not fit all and is not the answer. So a variety of different metrics are needed. And with that, I'm going to hand it over to Charlene to talk a little bit about the human component of our project.
Thank you, Lindsey. So basically, yeah, once the buildings were done and we had done our testing, it was then time to move in our residents. So LUCHA, one thing to know about affordable housing is that we don't have residents come to us asking, can I please move into that Phius building? They go through a process due to the critical lack of affordable housing in Chicago. They go through a process where they apply to be on a wait list. When their name comes to the top of the wait list, they get called, and then if they're qualified, they are offered a unit. And they are offered the next available unit. So our tenants come to Tierra Linda without really having made that choice on their own. And so we realize at LUCHA that we need to consider how we educate the residents who move into these buildings about why these buildings were built the way they were and the benefits that the buildings offer. So one way that we did that was we created a resident manual utilizing a template from Enterprise Community Partners, which you see at the top of the slide here. And that includes information about how to program the thermostat, information about the no smoking policy, information about the community, how to make their own green cleaners. So it's quite a bit of information, and we present that during a resident orientation. So as tenants moved into Tierra Linda, we would have basically an orientation with a group of them face to face and go through the resident manual and answer their questions. We also, at that time, did a survey with them so that we understood some of their concerns, some of their understanding of green construction, so that we had sort of a baseline of information. And then there was always the opportunity to follow up with LUCHA's Health and Wellness Fellow on any additional information or questions that they had about the buildings. Pause. So one of the issues is to consider occupant behavior relative to energy efficiency with these buildings. So as I noted with the resident manual, we provide information on how to program their thermostats, but I would say that most of our residents have not taken that opportunity to do that, even though we offer to help them with doing that. So that often can also impact how these units perform. Another item to consider is comfort levels. So we know that comfort levels personal by household, by individual. And for example, one of the tenants who moved into the Phius building, who was actually our first resident there, was family that came from Puerto Rico, and they were displaced by Hurricane Maria. So they came from there, they moved into the Phius building, and then shortly thereafter we had the polar vortex, which tested the performance of our heat pumps and obviously also tested her comfort levels. So those are things to also consider. And with our residents and where our buildings are located, there's always this personal perception of safety. And we know that within our community, there are still issues with crime and violence, and we are aware of an incident just across the street from our Phius building. So it's believed that that likely results in tenants spending more time indoors, and that's often what we see or observe. So you would expect that they might be spending more time cooking, more time watching TV, or kids playing video games, which I have seen when going into some of our units. And so it's also something to consider when you're looking at your use of energy in these units, and to consider that. LUCHA was also interested in the indoor air quality of these units and how that was also part of the Phius certification. And part of the approach to that was to have the no smoking policy, but we have found that it is sort of a difficult thing to enforce within these buildings. Also, we know tenants will spend time on the back porch smoking, thinking that they're not in their unit, but that can still go into, if somebody has an open window, into an adjacent neighboring unit. So that is something that we are still working on, and needs to be considered from an indoor air quality standpoint. Also from a cleaning standpoint, and I see this with our own staff, that like if it doesn't smell clean, it isn't clean. And so we work to sort of educate our residents on how that actually can impact the quality of the air they're breathing in their units. And that's why we included basically how to make their own green cleaners in the resident manual. Also cooking, like I had noted earlier, that our residents may be cooking more often than maybe a typical household. But as I noted earlier, we actually within Tierra Linda have 9 households who were displaced by Hurricane Maria, and they're all Puerto Rican, and we know that Puerto Rican food is largely deep fried. So how does that also impact air quality in the units? And lastly, from previous studies and just observing when our tenants move in with their belongings and their furnishings, you will see like things like vinyl shower curtains, and we're aware of how those off gas and how those can contribute to the quality of air within the unit. So it's all about really, partly engaging residents and educating them. But I think it's also important to note that when you're designing and modeling for these buildings, especially if you're doing that for affordable housing, to make those kind of considerations at the beginning so that you're aware of what kind of outcomes you're looking to achieve. So that's it for some anecdotal stories to share on the Tierra Linda study and the project. And so with that, we'll head off to the question and answers. Thank you.
Thank you so much, Charlene, and Lindsey and Connor. I'm going to introduce Lisa White from Passive House Institute US to moderate our session. Lisa, if you want to turn on your camera, you're there. So thanks everybody, and go ahead and take it away.
Great. Thank you all. That was great to hear all of that updated information and to see some of the new numbers, Connor, that we hadn't seen before.
Absolutely.
We've got a few questions in the chat, a few actually open questions in the Q&A, and go ahead attendees, continue to go plop some questions in there, and I'll kind of just go off of that. So one of the good ones I like is, given that the ACH is such a huge, the air tightness is such a huge contributor to the energy savings, what can we do in our state to amend that? Why are they so behind? So does anyone have a good answer to that?
I can start and just point out that the DOE low-rise multifamily code compliance study that we've been working on with eco-achievers has started to really dive into how multifamily buildings are performing with air changes per hour or air leakage. And a lot of the results we have coming back, it's promising that, you know, an ACH under 4 is commonplace and very much achievable. I think driving down to a half air change per hour is going to have us really reconsidering how we design the ventilation systems within our buildings. But some of it's going to be education from these types of studies to say, look, this is very much possible. And we're seeing, you know, pretty good results when we have really low air changes per hour when you combine with a balanced ventilation system. So maybe there's a way to get some of these things in front of our code officials here in Illinois. I think being on a few of those calls, you know, concerns about indoor air quality does come up, as well as constructability. So I think that this study does help show that both of those can be covered. So that would be my 2 cents to start. But I agree, Scott. I think it's an area that we as a design industry and also getting folks on the residential construction side of things all to come together around this.
So we, when I think it was the 2018 discussion was happening with IECC, we partook a little bit in that. And right now for our climate zone, we're supposed to be at 3 air changes. And Illinois has been at 5 air changes for a while. And then with the recent 2018, we went down to 4 air changes. And in thinking back on past discussions, I think that some of the concern was the ability of the trades to actually do this. And to kind of bounce off what Connor was saying, giving them the support and the resources so that the tradespeople, because that's who's constructing all of these buildings in multiple languages, and being able to give everyone the resources and guidance on how to construct to these levels. And I think some of, you know, if the states or all municipalities were enforcing it more, that would kind of prompt people to up their skills as well. And so going to more aggressive targets wouldn't be as much of a jump like Phius, because that would already be a common understanding. And so I think that there are multiple buckets and multiple parties that could help contribute to this. But we kind of, Phius or the Phius Chicago group petitioned to get a lower ACH when that conversation was happening, and it did not happen. And and so we're at 4 now, but hopefully, you know, when the 2021 standard comes out, we can be even tighter. So
yeah, I think that you guys both, was there an echo? Sorry. I think you guys both brought up pretty good points. And I do wonder if, Connor, you brought up like that once you get to a certain level of air tightness, now you really have to think about the mechanical systems, and then the people are worried about indoor air quality. So maybe it's that you have to make the jump with air tightness and balanced ventilation at the same time. Maybe that's part of the hurdle. I'm not sure, but I don't know, it would be interesting. And this kind of dovetails into another question people were asking about cost. And you showed the slide, Connor, of like it was somewhat like 50% of the savings was that ERV plus air tightness. And I wonder if the cost breakdown, if we have one, and if it looked similar to that, like was it 50% of the cost to get to that improvement over Energy Star? And then also, like as Lindsey mentioned, as more trades come along with this, like that cost could just completely be eliminated, and then the cost to, you know, get to Passive House is very incremental. So maybe Charlene could speak to cost, if you do know what the different parameters were, or different percentages, or just kind of the different buckets.
As far as percentage-wise, I wouldn't be able to talk to that right now, but the key items where we saw the increase in cost was the windows, because we had the triple pane windows the insulation cost along with the air sealing.
Mhm.
Those were probably some of the bigger buckets where we saw the increase in cost. And then also there was a slight increase with the mechanicals. So those were the main 3 buckets where we saw the cost differences between the 2 buildings.
Yeah, I'd just add we're still trying to dig in with the contractor to parse out where some of those additional costs really were coming from. It's, after the fact of the building being built now, and it's kind of difficult to do that, but we still want to understand, how, like you said, air sealing was one of the biggest contributors to savings, as was the ERV. And were those really, driving 50% of that cost increase, right? So trying to get to the bottom of that a little bit more. This project was also the first multifamily passive house project in Chicago, and I think always there's some, buildup of uncertainty from contractors when pricing the first project out. So I would hope that subsequent projects from this contractor or others would start to fall more in line with some of the other price premiums we're seeing out there.
Yeah, that was kind of the thought I had too. Like it's not a pilot project, but it was a pilot project, and pilot projects are always more expensive, so they're really not representative of the research they're trying to do. But I would agree. I would hope that moving forward, this contractor, maybe others, seeing more case studies, and as more data gets out there about this is achievable, and maybe that would come down. So there were some other questions, not a lot of other questions. So anyone, if you have more, but I'll just keep going then. Oh, maybe they're in the chat. Did you take materials and finish choices into account for VOCs and toxicity? So maybe that's a question for Charlene. I believe you had to for Indoor Air Plus certification.
Yeah.
Yeah.
Yeah. So LUCHA actually, part of this project also included a pilot for Enterprise's Health Action Plan. We were very interested in looking at respiratory issues, so we were very interested in indoor air quality, and that was actually part of the reason we were interested in Phius also. So finishes, hard surface flooring, low VOCs for, paints and caulks and adhesives. We wanted to have, filters within our systems to make sure that we were getting high particulate filters. So those were all things that were considered in the material selections.
Mm-hmm. But as Connor's graphs show, you can't control what they bring in.
Right. So it was pretty much flatline with total VOCs prior to occupancy. So that was all working really well. And then obviously quite a lot of spikes once move-in happened. And then after that, I thought maybe the most surprising piece was that CO2 and PM 2.5 were really pretty close to the reset acceptable limits, where total VOCs it didn't quite get there. And so my understanding with reset, it was in a lot of ways developed for commercial offices in the beginning, and I think it's probably easier to control things like cleaning practices, and maybe there's certain things that people aren't necessarily bringing into offices that they would be bringing into their homes. But that's an interesting takeaway to us.
Absolutely. So I think we probably have 1 minute to address, well, it's probably not enough time to talk about it, but there's been some questions about the gas. And there's a direct to Charlene, if you could talk about LUCHA's plan to phase out gas, or if maybe this has informed your decision for future development.
Sure. As I said, our consideration in doing all of this was looking at the utility costs or the energy costs for our tenants and the affordability component. Obviously also indoor air quality. So we are interested in looking at going electric or doing electrification. And we are having discussions right now with groups here in the Chicago area and across the US about doing something along that line. There are considerations that we want to make sure, like what Connor and the studies show, is that we're actually reducing the overall energy cost to the resident and not just going all electric when electric rates and then fixed rates play into that. So we are looking right now at the potential of getting some support to put a induction and a heat pump, like Connor was suggesting, at these two buildings in the future after we finish out the Slipstream study. So.
Great. All right, well, it looks like we're at time. So I just wanted to thank everyone and thank you three for charging ahead. And I hope this inspires other Chicagoans to keep the movement going here in Chicago. And yeah, so I'll turn it over to Katie now.
Thanks so much, Lisa. And thank you all again for presenting on this. I know this is a project that I've been following for a long time and had a chance to tour, I think, with Lindsey and Charlene back a few years ago when it was under construction. So it was really cool to see the study and how things have progressed over time. So thank you so much for sharing this. And I think it was a great final session in this conference to hear kind of this comparison and occupant data. So we really appreciate it. Thanks again to all of you. I'm going to just share a slide to thank our sponsors as well. Just one second. So thank you again to all of our conference sponsors. Without their support, we couldn't put things on like this. So we really appreciate everyone's support and putting on a 3-day virtual show. With that, we're going to move on to the conference closing.